In section 1.2, we are going to define the 6 trigonometric functions. And the first way that we'll do that is based on the unit circle. An important thing to know about the unit circle and why we call it a unit circle is that the radius is 1. So if you remember the equation of a circle from pre-calculus algebra as x squared plus y squared equals r squared, or you may remember a version that had h and k, where h and k were the center of the circle. Here, the center is 0, 0. So that's the reason h and k aren't showing up here. But with the radius of the circle being 1, the equation of the circle becomes x squared plus y squared equals 1. So every point on the outside of this circle or on the edge of this circle will satisfy this equation, with x squared plus y squared is equal to 1. So if you imagine a number line that goes from 0 to 2 pi, and it's being wrapped around this circle, each real number on that number line will correspond to a point on the unit circle. So the number 0 would correspond to our starting point where we start all of our angles on the x-axis. And because our radius is 1, that point has the coordinates 1, 0. That also would be the point that corresponds to the number 2 pi. And thinking about wrapping that number line around the circle kind of takes us back to that notion of arc length when we first had the definition of a radian, and we had that equation S equals r theta. So S is the arc length, r is the radius, and theta is the angle. So here our radius is 1. So if r equals 1, that equation just becomes S equals theta. So the arc length is equivalent to the angle. So in this equation up here, our r is equal to 1, so S is equal to theta. All right, so let's talk about the unit circle. Before we talk about the coordinates on the circle, I want to talk about the angles. There are only certain angles that we label, and they follow a very nice pattern. So I want to first label a couple of things that we know about a circle. We know the measure of the angles where we start. We've got 0 and 2 pi. So I'm in radians here. I'm going to put degrees up top too. So 0 degrees. And then we know the other half of the x-axis, we've got pi and 180. So 180 degrees, pi radians. So the top half of the circle is 1 pi. The bottom half of the circle is another pi. So in total, we've got 2 pi's. But let's think about if we took the top of this circle, we split it into 4 equal pieces. So y-axis already splits it in half. So I want to split it into 4 pieces. My circle is not quite to scale, but let's say that that top half is 4 equal pieces. So since the top half of the circle is pi, each of those pieces is 1/4 of pi, or pi over 4. All right, the first angle that we've created here is 1 pi over 4, or 1/4 of pi. The next one would be 2 pi over 4s, which we've already talked about is pi over 2. The next one would be 3 pi over 4s. And then the next one would be 4 pi over 4, which is pi. And we can continue this all the way around the circle. So this next angle is 5 pi over 4. And then we've got 6 pi over 4, which we could reduce. So if we divide the top and the bottom by 2, we would get 3 pi over 2. So I'm going to rewrite this one as 3 pi over 2. Okay, but 3 pi over 2 is 6 pi over 4s. So then we've got 7 pi over 4s. And then 8 pi over 4 is 2 pi. Okay, so instead of trying to memorize these angles, you can kind of count them that way. And I wish it were that easy, but there are a few more divisions on this circle. It's also split into 6 and thirds. So I'm going to do the 6 and thirds on another circle, and then we'll put them all together so we can see the full unit circle. Okay, so this time, thinking about the top half of my circle, just because it's easier to divide up a pi than to divide up 2 pi. So I'm going to think about dividing the top half of this circle, so just the pi, into 6 equal pieces. So I'm splitting each quadrant into 3 pieces. I'm splitting the top of my circle into 6 pieces, and that splits the entire circle into 12 pieces. So we're going to count these out, and then we'll put it together with the fourths to see the whole circle. So now I have taken the pie. I split it into 6 pieces. So you see here on the top of this circle where we're going from 0 to pi radians. If I split it into 6 pieces, then each piece is 1/6. So we're counting by 6. So this is 1/6 of the pi, or pi over 6. This is 2/6 of the pi, which would be 2 pi over 6. That one we can simplify into pi over 3. So this angle on the unit circle you'll see is pi over 3. And I'm going to count all the rest of them out and then go back and simplify at the end. So try to make this less confusing. All right, so we got 1 pi over 6, 2 pi over 6. Next would be 3 pi over 6, and then 4 pi over 6, and then 5 pi over 6, and then 6 pi over 6 is pi, and then 7 pi over 6, 8 pi over 6, 9 pi over 6 at the bottom, 10 pi over 6, and then 11 pi over 6, and then 12 pi over 6 would simplify to 2 pi, right? And so all of these angles where the top and the bottom have common factors, we'll simplify those, and then we'll put it all together with the fourth angles. All right, so that you can see where they go, I'm going to add in the fourth angles here. So halfway through the quadrants. Again, my circle is not quite to scale, but we had a pi over 6. 2 pi over 6 was pi over 3. Now go ahead and put these 6 back on. So there are our 6 labeled and reduced, and now I'm going to put back in the pi over 4s that are missing here. And that is all of the angles, the special angles that appear on the unit circle. Okay, I wanted to show you those patterns because not only do we need to know the angles on the unit circle, we also need to know the coordinates, so the x and y coordinates that correspond to each of these angles. So each angle has a point, an ordered pair, and the x coordinate and the y coordinate are very important for our trigonometric functions. Okay, so I'm taking the angles off just so that things don't get too cluttered here. And we're going to put the ordered pairs on. And they also follow a pattern. So you don't have to memorize the whole circle as long as you can remember the pattern. Also keep in mind that the x squared plus the y squared has to equal 1 because the radius of the circle is 1. So let's start with this first point here. Oops. This first point here at the angle 0 or 2 pi. So if we're thinking about our coordinate plane, the radius is 1, then we're moving just 1 unit in the x direction. So the x coordinate is 1. And we're not moving anywhere up or down, so y coordinate is 0. So at this point, the coordinates are 1, 0. So let's go ahead and label all of our quadrants here, since those are the easy ones. So up here, x coordinate is 0, and the y coordinate is 1. Down here on the left side of the x-axis, now we're moving to the left, so we got -1 as our x coordinate, and 0 is the y, since we're not moving anywhere up and down. And then at the bottom, x is 0, y is -1. Now, something to remember about the coordinate plane, in the first quadrant, both x and y are positive. So everywhere over here has a positive x and a positive y. In the second quadrant, because we're to the left, our x's are negative, but we're still above the x-axis, so the y's are positive. So in quadrant 2, x's are negative, y's are positive. Let me write it this way instead. Pi positive x, positive y. Over here, we've got negative x and positive y. Down in the third quadrant, our x's are negative and our y's are negative. And in the fourth quadrant, the x's are positive, but the y's are negative. So all of our points on the circle are going to essentially be the same. We've got 3 that are going to repeat, but the signs are going to change based on which quadrant we're in. All right, so here's some patterns that I want you to know. For each of these coordinates, all of the denominators are 2. The numerators are square roots, and the number under the square root is just increasing by 1 for the y coordinates, and they're decreasing for the x coordinates. So let's do the y's first. Starting at 0, and then we go up to square root of 1 over 2, which is just 1 over 2. And then numerators increasing under that square root, so we got square root of 2 over 2. And then moving up, we've got square root of 3 over 2. Continuing that pattern, next we would get to square root of 4 over 2. And the square root of 4 is 2. 2 over 2 is just equal to 1. So all the denominators are 2. For the y coordinate, our numerators are increasing. So going from 0 to 1, we're increasing. The x's are starting at 1, so they're going to decrease down to 0. So the first x coordinate here would be square root of 3 over 2, and then square root of 2 over 2, and then square root of 1 over 2, which is just 1 over 2. We're going to have those same coordinates in quadrant 2, but the x's are going to have to be negative. So down here, we still got a square root of 3 over 2 and 1/2, just like this point, but the x is negative, so negative square root of 3. Y's are still positive, so positive 1/2. This one is still square root of 2 over 2, square root of 2 over 2, but the x has to be negative. And looking here at our x's, we've got 0 here, and as we come around the circle, look at those numerators are increasing, but they're all negative because of the quadrant. Our y's are starting at 1 and then coming down. All the denominators are 2. Same pattern in the third and fourth quadrants. We just have to pay attention to the signs. All right, so at this next point, if I'm trying to figure out, like, should it be square root of 3 over 2 or should it start with 1/2 and square root of 3 over 2? What I would do is look at the point above it. So looking at negative 1, 0, my x's are starting at negative 1, and then coming around the bottom of the circle, coming around this quadrant to the bottom of the circle, I need to get down to 0. So if I want to go from 1 to 0, my numerators are starting high, they're decreasing. So this is going to be a negative square root of 3 over 2, negative square root of 2 over 2, and negative 1/2. My y's are starting at 0 here, and they're ending up at a 1, so they're going to increase. So I'm going to go 1/2, 2 over 2, 3 over 2. And these should also be negative because I'm in the third quadrant. All right, and we're almost done. Same pattern in the fourth quadrant. Here my x's are starting at 0 and they're going up to 1, so they need to be increasing. And in this quadrant, the x's are positive. Right? Now looking at the y's, they should be negative in the fourth quadrant, and they need to go from negative 1 to 0. So I'm going to be decreasing the numerator, so starting with the biggest and going down. Negative. All right, there's all the points on our unit circle. If you can remember the first quadrant, then it's usually you're usually able to recreate the rest of it. We'll find out later on in this chapter that we don't really need all of it. If you know the first quadrant, you can figure out all the other values.